Welcome to the Fuel Pulse Show podcast. I'm your host, Eric Bjornstad, your guide through the ever-changing world of fuel. Now, if you haven't joined us before, the Fuel Pulse Show is for anyone who uses fuel or who has things that use fuel, and that means either at work or at home, and that means the Fuel Pulse Show is pretty much for everyone, especially anyone who has a job that requires them to take care of fuel, to manage fuel or fuel storage systems, because they need to use that fuel to get the job done, whatever that job may be. So if any of that sounds at least a little bit like you, then this is the show for you. So what are we going to talk about today? Well, previously, in previous episodes of the Fuel Pulse Show, we talked to some individuals about this issue of storage tank corrosion and microbially induced corrosion. Both of those are problems that are really plaguing fuel storage systems around the country, and they're not getting any better. But not all corrosion is exactly the same. There's a specific type of corrosion that is especially problematic for fuel management professionals, and that is vapor space corrosion. And so to talk about that today, we're joined by today's guest on the Fuel Pulse Show, Kelly Baker. Now, Kelly is the Business Development Manager for Zerust Oil and Gas for North America, and he works with a team that develops new applications for volatile corrosion inhibitor chemistries to apply those to the real-world situations that they're needed in. Now, Kelly's work with his team over the last 10 or so years has resulted in numerous patents and industry innovation awards. And so he's going to be a really good person to talk to about this subject, which again is kind of a specialized subject, but it's really important. So we're really glad that Kelly was able to join us today. Now, Kelly is a graduate of the University of Utah, go Utes, and currently resides in the great state of Texas, home of the Longhorns and Great Brisket, and more sadly, though, the Dallas Cowboys. So, Kelly, welcome to the Fuel Pulse Show.
Thank you, Eric. I appreciate the invitation.
Well, yeah, we really appreciate you joining us today. So to kind of kick things off, it was a few years ago, I happened upon the, I don't know if it was 2015 or 2016, it was the report from the EPA about microbial or microbial-induced corrosion in storage tanks. And in that report, they referenced this phenomenon that they called vapor space corrosion. And I remember in the report, I don't remember exactly what year it was, maybe it was from 2011, but they said that there was a point in time where it started being noticed. People started finding these instances of vapor space corrosion in their systems, and they started reporting it. And then, of course, the more people noticed it, the more people noticed it, and you started getting increasing your reports of it being out there. Now, your expertise happens to be in this discussion of vapor space corrosion. And I know in our audience, we have a lot of fuel management professionals and people who have to look after and take care of fuel storage tanks. So can you just kind of kick things off a little bit by describing for us in as simple or as complex as you want to make it, what vapor space corrosion is?
Well, I think if you ask different people in different settings, you're going to get different answers. Microbial corrosion is not the same as vapor space corrosion as far as I'm concerned.
Mm-hmm.
The cause of microbial, of course, is the bugs, and they create an acid.
Mm-hmm.
Now, vapor space corrosion typically relates to a enclosed space, and in the case of tanks, that could be under the floor, that may be above the product in the vapor space under, say, a fixed roof.
Okay.
And there will be different parameters that cause that corrosion. Under the tank floor, which is predominantly the problem, it's based on having moisture, it's having oxygen, and you put the two together with an iron or a steel, and you create a corrosion cell. So the vapor space is a problem because there really isn't anything available in the market as of 2000, well, 2000, early 2000s, that would protect the underside of the floor in those vapor spaces. The main corrosion control method for decades has been cathodic protection.
Okay.
But it is only effective where that steel is in contact with the substrate so that that electric current can get to the steel floor.
Well, and for
So
this cathodic protection, uh, is there a I don't want to say is there a limit to the size of tank that tends to use, but basically for cathodic protection, if you had, let's say, 100,000 gallon tank, or a company of sufficient size to have multiple 100,000 or 500,000 or million-gallon tanks, you would expect them to be using something like that. But for smaller entities, like, let's say, I mean, you could even say like a public utility or a hospital, or some of the people we have down here in Central Florida, fire departments, people like that, cathodic protection really isn't something that they would tend to be a sufficient scale to use, or am I wrong?
well, actually, in Florida, most above ground storage tanks, and off the top of my head, I don't remember what size they kick in, they require dual containment and
Yep.
cathodic protection.
Okay.
But as of 2014, they also approved the use of vapor corrosion inhibitors,
Okay.
which are the chemistry that's used in a vapor space corrosion event.
Okay.
And so that's the state of Florida. That's not blanket across the country. It depends on whether it's a PHMSA regulated tank or a non-regulated tank like you might see at a hospital. Or I'd have to check those. I don't deal much with the public utility tanks.
Okay. So it does vary by state. Some states like Florida have those rules. Do they have them in Texas?
Not it's not the same jurisdiction. So in Florida, it's the DEP. It's the Department of
Yes.
Environmental Protection that regulates. In Florida, it's the fire chiefs. So it's not the same level of regulatory supervision unless the owner says, I am going to follow PHMSA rules, which are probably as stringent, if not more so, than most states.
Okay. Okay. And if it's the fire chiefs, does it intersect at all that you know of with like NFPA 110?
I don't know that the NFPA documents because they don't really, well, I don't really deal with them with the oil and gas owners.
Oh, okay, okay, I see, I see. Okay, so how big of a problem? And this may be this is kind of a broad question. So again, you can be as specific or as broad as you want. But how big of a problem is vapor space corrosion out there? I mean, what prevalence have you seen in the industry? If you could summarize that.
Well, corrosion doesn't sleep. All we can do is try and slow it down. So every tank that you see or every pipeline that you see is going to experience corrosion over its life. If you look at documents like API 653, they give guidance as to how long you can go before you have to do a formal inspection on an asset. So it's prevalent everywhere. The question is, what are the owners doing and what have they been doing to slow that corrosion process down so that they can extend the life of an asset and maximize, obviously, the return on investment?
Okay, so it's going on everywhere. Not doesn't necessarily, I guess, look the same everywhere, or as serious everywhere. But just like we would say, almost every tank that you're going to find has microbial content of some kind in it. But then it's a matter of when you get into specific situations, you're more likely to see those problems, manifested in a visible way or detectable way.
Actually, we do see microbial corrosion under tanks, but it's not really the prevalent type of corrosion. It's usually it's that moisture oxygen concentration cell. It's there could be microbes in the sand. They do a pretty good job of trying to install clean sand or concrete pads. And so the microbial thing in above ground storage tanks is there. I wouldn't call it the prevalent corrosion method. I see it more in pipe casings, the annulus of a pipe casing. You'll get microbial in there because you get groundwater inside. Typically, the owners are trying their best to isolate the storage tank floor from the groundwater. So they put in release prevention barriers. They use clean sand. But so the prevalent corrosion mechanism that I see is that oxygen, moisture. It could be debris that is brought into the sand pad. Sometimes you'll find clay balls because somebody's been walking out in the yard and then walk into the sand before they put the plates down. Sometimes there's hate to say it, but maybe there's a welding rod left behind. Someone didn't see it and pick it up before the plate went down. And as soon as you get metal on metal contact, you create a corrosion cell. So for the most part in the oil and hydrocarbon liquids arena, we're not seeing microbial. Now, having said that, some of the new biofuels are having a little bit more of an issue with microbial, whereas the traditional hydrocarbons, not so much.
Okay, and I think I got the sense when you were talking about like things happening with the sand pit that you're referring to the outside of the tank, whereas what I was
Bottom
alluding
side.
to I was alluding to inside of the tank. Yeah.
Okay. So inside the tank, vapor space corrosion is really only happening above the liquid.
Sure.
And and that's dependent on what's in that atmosphere. So in a crude oil tank, you'll get H2S
Yep.
and SO2 gases, and those molecules will absorb to the steel, and they'll certainly eat through the coating. Or now, as far as microbes in that area, I haven't seen anything on the inside of the roof. Now, from an inside perspective, if you've got a crude oil tank, for example, and you've got a water layer at the bottom, that's produced water typically, and that might have anything in it. So top-down corrosion, it's not a vapor space corrosion, but it is certainly prevalent, and they, for the most part, coatings deal with that. It's from our perspective, the vapor space is on the underside of the tank, and from bottom up.
Okay. All right. And so I was going to ask the mechanism by which it would work. Now you already described like in a crude oil tank, you get the H2S and the SO2 that comes up, and that, correct me if I'm wrong, that will actually condense with water vapor to form sulfuric acid as it absorbs onto the metal, and that's what essentially corrodes the surfaces.
In the inside of the tanks, Eric, yes.
So for the outside of the tank, that what you're talking about, are there any unique mechanisms for causation for vapor space corrosion? And has anything changed from the past that makes it more prevalent now?
So the mechanism is that exchange. So you fill and empty a tank. And as you do, you're moving the vapors from underneath the tank in the sand or on the concrete, whichever the pad for that tank floor is. You're moving those vapors. And as you do, you're bringing in moisture, you're bringing in oxygen, or you're pushing it out. But that combines on the steel surface, and the three legs of corrosion are then present. You've got the steel, you've got the oxygen, you've got the moisture. And so a corrosion cell starts. If you've got other contaminants in that sand, then they can actually add to that corrosion rate.
Okay.
I think I answered your first question. I'm not sure I answered the second one.
No, I think so. And to be fair, what what my area of expertise, I actually deal a lot more with what goes on inside of the tank than outside. So like when I'm reading the when I was reading the Battelle report, as we call it, the that EPA report, and they were talking about vapor space corrosion inside, and they were talking about the fact that it was linked to the microbial activity, because the certain kinds of microbes will produce lightweight acids, and the acids then volatilize. They're light enough in weight that they can volatilize up into the vapor space inside of that tank, and then they condense onto the metal surfaces, and they corrode pretty much everything metal that they come into contact with. So that's kind of the area that or the mechanism
Okay.
that I'm most familiar with.
Okay. So to
Yeah.
that, certainly you've seen an awful lot of cases where that is going on top of the rafters in, say, a cone roof tank. And you'll see that if you're looking from the outside, you'll see a strip of corrosion and maybe an entire hole along the top of the rafters, because now they have a place to rest, reproduce, and create that acid. So that is certainly a corrosion issue for roof replacement
Mm-hmm.
or maintenance.
Okay. Okay. Um, if if I was talking about inside of a tank, I would ask someone, are there certain components inside of the tank that are more sensitive or more prevalent to corroded damage, like STPs, things like that? Would it be correct, or would it be an oversimplification to say that it's a lot simpler to look on the outside and see what areas are? I mean, the outside, you've got what areas on the outside of a tank system are most prevalent to seeing this kind of vapor space corrosion on the outside that you've been talking about?
Well, the being on top of that roof, you
Hmm.
certainly can tell. Now, most people don't want anybody walking on their roof, because if it's thinned, possibility that they could go
Yeah.
through or step through.
Yeah.
So that's roofs are really, in my opinion, and I'll be honest, I don't spend as much time on them as I do, or in discussion on roofs, as I do with tank
Hmm.
bottoms. Um, but they're an interesting animal, because there's not anything you can do to them short of taking the tank out of service. So
Not from a preventive
you could have
standpoint.
somebody. Well, the biggest preventative is an internal coating,
Okay.
and and usually the internal coating is matched to what the expectations of gases and microbes might be, and they're very effective, except
Hmm.
for the fact that once the roof is built, if you're going to coat it after the fact, there is no way to get coating to all the surface areas, even
Mm,
from scaffolding.
sure.
Being able to coat on top of the I-beams that are holding
Hmm.
that roof up, underneath the roof plate, is a near impossibility. Um, and then you do welding, and if so you kind of leave the coating to the last thing, and so your vulnerable areas are on top of your supports for
Hmm.
that roof.
Okay. And for those vulnerable areas, I know it's dependent upon certain parameters, environmental parameters, but just again, at the risk of overgeneralization, how quickly can uh, real tangible damage from vapor space corrosion manifest itself?
Well, I'll be the first to admit that is not my area of expertise. We see tank bottom failures, the bottom
Uh
part,
huh. Uh
um,
huh.
where you might get a pinhole in from a corrosion event.
Okay.
It can be as quickly as 5 years, and
Okay.
and and maybe last for 50. Now a roof typically they're planned for a 20-year life cycle.
Okay.
That's the way I understand it. So
Okay. Okay. Um, so for has how is the industry it's as a whole, how have they been treating this as a problem? Have they Is it one that they have been quick to come around? That's something that they should take seriously, or is it still pretty much we'll cross that bridge if slash when we come to it, and we don't think that we will. So talk to us next time.
So let me back up just a little bit. You're familiar with NACE or AMP now? They're called National Association of Corrosion Engineers, and
Yep.
sorry, AMP. I don't recall the acronym. They did a study in 2016, a global study, looked at the cost of corrosion.
Yes.
And in that study, they said that corrosion is costing the global economy approximately $2.5 trillion a year. If you look at specifically at the oil and gas industry in the United States, it's about 18, depends on which parameter you use. It's about 18 to $25 billion per year in cost because of corrosion. So we first started building tanks 100 years ago, 100 and plus, 120 years ago. They've been aware, of course, steel will corrode over time. And so 60, 70 years ago, they started using cathodic protection. And cathodic protection works as long as you don't have those gaps between the substrate and the steel. So vapor spaces.
Yeah.
And so the industry has been using cathodic protection. It's been efficient. There are studies that say that only 35% of the tanks out in the marketplace actually have cathodic protection underneath them. They've been very diligent in trying to change foundation designs using different materials, better sand, concrete, asphalt. In the UK, it's bit sand. So there's been a real drive to find ways to reduce the corrosion rate. Can't stop it. Now, the difficulty is that when you find something that works in a certain geography, environmental, weather, and all that kind of stuff, it may not work in another geography as well. And so it is an ongoing battle. Corrosion inhibitors or vapor corrosion inhibitors for vapor space have been around for 70 years. But it's only been introduced into the oil and gas market in, say, the last 15 to 20.
Okay.
And the issue with oil and gas is we don't like to try new things readily. Nobody wants to be on that bleeding edge, right?
No.
And so,
because what if it doesn't work?
Well, yeah. Does it do harm, or is it inert if it doesn't work? Well, what we're finding is that it does work. It's now been written into API documents, be shortly in a NACE AMP document. And the U.S. Department of Transportation, PHMSA division, is currently doing testing on VCI with the intent that if they prove that it works, they'll adopt it into PHMSA regulations.
Okay. All right. So I want to ask you. Well, I was going to ask you two, but I want to ask you three questions. The first thing, what you just said a minute ago, that depending on what environment you're in, some corrosion inhibition technologies may work better in some than others. So the question that came to my mind is not what's the difference, but basically what works. What kind of environment will that kind of protection not work in where it works better in another? Like what works in Florida, which has hot, humid, versus if you go up down in Minnesota in the spring and summertime, just not so hot or humid. What's the difference, I guess?
Well, so in some parts of the country, you are dealing with the hot and cold. Inhibitors will in ambient conditions will evolve from the source of their inhibitor at a certain rate.
Okay.
In a cold environment, it will be a slower rate. In a hot environment, it will be faster. So it really depends on temperature, what's going on there. Moisture content, higher humidity, more water has an effect on the life of that chemistry and how often you would have to replenish it.
Okay.
We've seen situations where coastal areas were affected by a hurricane and blow a lot of chloride content water into an environment, and they will have a significant impact. So beyond just the geography, where did you source your sand from? Is it off the beach of Galveston, or is it inland where the chlorides are going to be lower? Did you do something to that sand and wash it? I mean, there's so many different parameters here, Eric. It's impossible to say that there's a one size fits all. In fact, we would say that every application is different.
Okay. Okay. All right. So that was question number one. Question number two, and number two and three are related. So I'll ask them in sequence. So number two, you talked about cathodic protection. So I'm going to ask you to explain for the non-scientists or the non-technical people in the audience what cathodic protection is and how it works to do what it's supposed to do. And then the third one, which is related to that, is the new protection chemistries, the things that you're working on and that your company are working on. Tell us about those and how they are maybe an improvement upon cathodic protection, how they compare to it. So go.
Okay. So anybody that watches this webcast that knows me will tell you I am not a cathodic protection expert.
Okay.
But so
well, neither am
what
I, so
know,
we're the same.
But what I do know is that cathodic protection is based on an electric current. It's moving molecules from an anode to a cathode. So the anode is a depletable substance. Your cathode is your steel floor.
Okay.
So what in a corrosion event, it wants to take away metal. If you have a surrogate, the anode, that can be depleted, then it won't take away from the steel floor, and it's transmitted. It's a electrical circuit.
Okay.
And so that's what I understand about cathodic protection. There are some geniuses in this country that understand it very, very well, and I would defer to them.
Okay.
So a cathodic protection system is an electrochemical reaction.
Yeah.
Whereas a vapor corrosion inhibitor is a chemical reaction. And so you take away the electricity, you apply a VCI, it does everything based on its chemical reaction. There's no power or anything needed. The thing about CP is that, as we mentioned before, that steel has to be in contact with the substrate in order for it to pass to the steel and protect it. So that works very well in a sand environment. It doesn't work at all in a concrete environment. Quite frankly, you don't have enough steel in contact, and passing electricity through the concrete is a difficult prospect.
Okay.
So the VCI chemistry, and there's many manufacturers out there, and the chemistry works basically the same way, just different, special sauces, if you will, in each of the manufacturers. The chemistry, it evolves from its source, and that can be a powder source or a liquid source, depending on how you deliver it to that vapor space. But the vapor space needs to be enclosed. So you don't want to put it in an electrical panel where you've got a fan blowing the air through the panel, or in the top of a roof, underside of a cone roof, where you've got vapor recovery systems that are pulling that vapor out. So the molecules have evolved much like an air freshener molecule evolves. it works under a partial pressure. So it wants to equalize its molecule with the other molecules in that atmosphere. And as soon as it reaches that equalization, it stops evolving. Now, as the molecules are lighter than air, they will actually percolate up to the steel surface. And as they reach the steel, they absorb and take precedence on the steel. And so the main method is a blocking mechanism in chemistry terms.
Okay.
And it's blocking oxygen and moisture from getting to the surface. Now, the second mechanism is a neutralization, and that's probably the wrong word, but it neutralizes water as a contaminant.
Okay.
So the water that comes in contact with the steel surface won't actually interact with the steel and the oxygen and create that corrosion cell. So those are the two main mechanisms that it works under.
Okay. Yeah, and so if you've got a neutralization mechanism like that, if you're in a humid environment, would it be fair to say you'd have to, I don't know, use more of the chemistry to maintain the same level of protection as, let's say, if you were out in Las Vegas or whatever?
So in almost every case, we use a more than necessary percentage concentration. And the purpose of that is you're going to have vapor molecule losses because there is no such thing as a perfectly sealed tank environment, for example. So the initial concentration is intended to get you 7 to 10 years in a relatively well-sealed environment. What affects that is the amount of water that might come in. There are some sites where flooding is absolutely a common occurrence. And again, it comes back to how is the tank designed? How is the foundation designed? So there's a lot of factors there, but the idea being you put enough in for 7 to 10 years and then you look at replenishment.
So, and what you said a few minutes ago when you were talking about cathodic protection, and you were talking about how it has to be in contact with the substrate, and so you contrasted having a sand floor versus having, I guess, a concrete floor. That concrete, there wasn't enough metal in contact with it to make, I guess, the cathodic protection as effective as you would want it to be. So basically, if somebody has a concrete floor tank system, they would be the ones where the alternative BCI would be what they would want to look at. I mean, is that a correct way of thinking about it?
So let me say that for the most part, concrete's pretty good application for a tank bottom because the pH of the concrete is relatively high. The question comes down to how much vapor can get in there and condense on the steel.
Okay.
So we see lots of tanks that do just fine corrosion rate wise with a concrete base, and we see others that VCI is really the only way to slow that corrosion rate down. Remember, their goal is to get to the next inspection cycle and have as few repairs as possible.
Yeah, that's always the goal, to pass the next inspection.
And hopefully not have to replace that floor. So,
yeah.
You talked about biofuels a little bit, or some of the things you learned from the EPA.
Yep.
Methanol is probably one of the hardest products to contain. Sorry, ethanol, my mistake. Because the vapors come off of the ethanol, they get to the outside of the tank. You see some browning or blacking on the outside of the tank. And then the rainwater washes those molecules down the side of the tank and underneath the floor. And so, acetic acid is formed by the bacteria, the ethanol vapors, and water.
Yep.
And so we see a lot of ethanol tanks on concrete pads. And really the best option is to seal that environment and add a VCI under it because it changes the pH, so it makes it uncomfortable for those microbes. And then it provides that vapor mechanism. So
okay. Yeah.
That's an example, real world, of what you were talking about.
Yeah. So, and hopefully this won't be too generalized of a question, but so if you've gotten an inquiry from somebody who has a tank system who believes that they need better corrosion protection. So what kinds of things do you take into account when, or if they were having you come in and do an assessment and figure out, uh, what they needed, how much they needed, what would you be looking at? What would they expect you to do in order to properly assess their issue or their
So,
situation?
so there's two different scenarios that happens, Eric. We we get asked for tanks that are out of service where they've just done a floor
Mm-hmm.
scan and they realize the corrosion rate is such that they need to slow it down to get to the
Yep.
next inspection interval.
Yep.
We have, on the other hand, we have um, owners that are partway through their inspection cycle, but
Mm-hmm.
maybe a sister tank has a problem, or maybe their CP system doesn't quite meet criteria.
Okay.
Now, I have to be very careful in that statement because if that is a DOT FEMSA regulated tank,
Yeah.
today you cannot use just VCI. You have to have a working CP system.
Ah.
So let me be very clear on that we don't want to get them in trouble with
You don't want to give
FEMSA.
the wrong impression of what they're going to need to do.
So um, then we ask, what we're really trying to determine is what's the best method of delivery? And that
Mm-hmm.
can be in a sand pad, that can be through monitoring ports. On a concrete pad, it might be different ways. It's different if the tank's in service versus it's out of service. So we ask questions, what's the condition of the tank? What's the design of the tank floor? Once we know that, we will be able to calculate an estimated vapor volume,
Okay.
vapor space area
Yep.
underneath that tank. If it's got sand, that sand takes up a percentage of the vapor volume, but not all of it. And that's once we have an idea of what that vapor volume is, then you can calculate a concentration of inhibitor to
Mm-hmm.
a volume of water if you're using water to deliver the inhibitor.
Okay.
If you're using a powder, there's other ways to calculate that as well. So each situation, that's why I said early on,
Yeah.
every tank is a different project.
Yeah. Yeah. Okay. Um, so, where do you see? Usually, I ask this kind of question to different parties. Basically, for vapor space corrosion on a whole, what direction do you see the industry headed? Um, do you see VCIs becoming? Do you see some new VCI chemistries being developed that are going to be even more effective? Do you foresee that there's going to be a whole lot more tanks across the country that are going to be having this problem because people still aren't paying as much attention to it? Um, Basically, what direction do you see things headed?
Well, I think the tank owners are fully engaged.
Mm-hmm.
There's regulatory issues that they have dealt with in the past, and I don't see a whole lot of oil and gas industry owners that are not 100% engaged, and
Yep.
we just need more tools in the kit. That's
Ah.
really the buzzword, right?
Yeah.
We've only had cathodic protection or tank foundation design. Well, it's hard to change the tank foundation design without a whole lot of money. You can take the tank out of service and install a CP system. Um, the the industry is looking for that tool in the kit to reduce downtime
Mm-hmm.
and extend life inspection
Yes.
cycle.
Yeah.
And so we're seeing VCI is a very cost-effective option because you don't have to take the tank out of service in most cases. And I say almost all cases. if you can apply a VCI, it can usually be done while the tank's in service. Back to that thing about FEMSA though.
Yeah.
Do not want to install VCI when your CP system is not working. You've got to fix that. Now, FEMSA regulated tanks probably make up, I don't know, I'm going to guess here, maybe a quarter or a third of all the tanks out there.
Okay.
When you consider there's a lot of 500 barrel tanks or 2,000 gallon.
Yep. 20,000.
20,000 gallon.
Yeah.
Sorry. Tanks in the upstream. So there's a lot of tanks out there that VCI can easily be applied to very cost effectively. And so the industry's just looking at it as, okay, I've finally got a third tool in the kit.
Mm-hmm.
Tank design, CP, VCI. I've now got more options based on what my needs are.
Okay. All right. Well, Kelly, where can people go to find out more information about what you do and what you can do for them?
Well, if you're looking for our website, it's zerust-oilgas.com. There's a lot of information at API. If someone's familiar with API documents, take a look at API 655.
API 655. We'll be sure to put that in the show notes.
And NACE AMP is about to publish a document. We expect that to be published later this year, and I'm happy to share that once it's published.
Okay, great. All right, last question. This is a really difficult one. Outside of Dallas-Fort Worth, how many people actually like the Cowboys?
You don't ask that from a person coming from Houston, right?
Well, I imagine there's probably plenty of people in Houston that don't like them.
Well, I'm more of a hockey fan, Eric, and so I can tell you that just because of the Dallas Cowboys, I don't really like the Dallas Stars either.
Well, of course, I'm old enough to remember the Dallas Stars came from Minnesota. It used to be the North Stars, I think. Yes.
Correct.
Yeah, people always underestimate how old I look. I am old enough to actually remember the Minnesota North Stars. All right, well, Kelly,
being from Florida. Sorry, Eric, being from Florida, depending on what part you're in, quite like the Tampa Bay Lightning.
Well, nobody in Florida is actually from Florida, as you know. Everybody ended up there. I mean, I grew up all over the place. My father worked for Department of Defense, so I've lived overseas. I've lived in Maryland, Tennessee, Alabama, lots of different places. I did adopt the Edmonton Oilers as my team a long time ago. And as of this recording of the podcast, they actually just made the Western Conference Finals. So we'll see how they made. But to your point, Florida, the Tampa Bay Lightning have done a fine job. Well, and the Florida Panthers had a really good year too. So, but it's because they stole everyone from other parts of the country, because nobody in Florida actually grew up playing hockey. So, all right, well, Kelly, thanks. We really appreciate you coming on for this episode of the Fuel Pulse Show. We will link to some of the resources that you talked about in the show notes. And for our audience, we appreciate you joining us. If you liked what you heard, then feel free to subscribe at your favorite place that you get your podcast, whether it's iTunes or Stitcher. If you liked it well enough, please go on and give us a good rating, because that really helps us and also helps people find us. So anyway, thanks again, Kelly, for joining us. And we will see you all next time at the next episode of the Fuel Pulse Show.